Okay, so thank you for joining me today for this workshop, Introduction to Photogrammetry and Mobile LiDAR Scanning. I'm Dr. Francesca Albrezzi, and I'll briefly introduce myself while you're filling out that welcome survey if you haven't had a chance to yet. I'm a digital research consultant at UCLA where I help scholars integrate digital technologies into their research process. I trained as an art historian and a cultural studies scholar, but I'm what you might call a digital humanist. So, digital humanities, or DH, as it's sometimes called, is a field that considers the productive tension between computational methods and humanistic inquiry. So, my research involves using extended reality technologies such as AR or VR in GLAM institutions. So, GLAM standing for galleries, libraries, museums, and archives. So, that's my area of expertise. And you'll see that sort of come in and out of today's presentation, I'm sure. But the focus for today is a little more broad than that. And I'm just going to take a second here to pause and let someone in to join us. Great. So as I turn my camera off now so we can focus on the slides, I just want to briefly note, for those of you who may not have heard yet, the Office of Information Technology, or OIT, which works closely with the Institute for Digital Research and Education, or IDRI, has been rebranded. And we are now the Office of Advanced Research Computing, or OARC. You can read more about the name change from the Vice Provost, Jim Davis, in his welcome address on the new website that we have up here, and you can go to oarc.ucla.edu to see that. So keep a lookout there and the IDRI website for new trainings and events, as well as the workshop portal if you want to find any new workshops like the one we're giving today, and that's at workshops.ucla.edu. Okay, so now on to the workshop. As you may know, 3D models can be formed in a number of different ways. Two common survey methods that result in 3D models are photogrammetry and light detection and ranging, or LiDAR for short. In today's tutorial, I'm going to introduce you to the production workflows that are fairly typical for each of these methods of capture and some of the hardware and software that is used. Most of today's presentation is canned because rendering models often takes a lot of processing time, which would mean a lot of sitting around and waiting for the computer to do its thing, which is not ideal for a workshop. However, I will take you from start to finish on these methods as best I can, and I hope you will try them out at home and reach out if you have any questions at all. We will start with photogrammetry, and then we'll move on to mobile LiDAR, just so that you have a sort of sense of where we're headed today. So a form of photogrammetry has been around since the beginnings of photography in the mid-19th century, believe it or not. The term usually refers to the method by which 2D images are compared and combined using optics, projective geometry, and computing to produce a 3D model. This method of image overlap to create a dimensional model is applied in many object-oriented disciplines such as archeology, topography, or topographic mapping, architecture, engineering, manufacturing, quality control, police investigation, cultural heritage, and geology, and the like. So what does that mean? Well, to put it simply, in this method, you move around an object, taking a lot of pictures, and then you feed those images into a software program that uses math to stitch them together, like a three-dimensional puzzle. This results in a 3D model that comes with a photorealistic texture layer. And for those of you who are just joining us, I'm going to put in the chat the welcome survey and the link for today's slides. So your model will improve the more pictures that you take and the better camera equipment that you use. However, you can get some very useful captures with a camera phone, which is what I'm going to show you today. Also, it's worth noting that the higher amount of images and the greater their quality, which is usually reflected in their file size, the more time it will take for your model to render, and the heavier or the bigger in terms of file size your model will be. So why is this important? Well, it all depends on what you want to do with your model. If you're looking for for minute details on a work of art, high resolution images are going to be more important than if you're capturing a landscape for changes in urban development over time. This is often a trade-off with this kind of work, and you will want to make those calculations for yourself as you begin working on a project. And you'll see what I mean by that in these two examples that I'm about to show you. So typically we distinguish between aerial or orbital photogrammetry and ground or close range photogrammetry. And here are two examples of each. The one on the left is of the castle town of Monemvasia in Greece. I believe I'm saying that correctly. This was completed by a commercial company that have experience in land surveys and aerial mapping for businesses, public work projects, and archaeological sites. And they used 700 photos to produce this model. So I'll quickly jump over to Sketchfab so we can actually see this model live. And you can see what this type of render produces. So this is probably using a drone to capture all this from above. But what's really great is when you zoom in, you can actually see you get quite phenomenal detail on these buildings and this landscape. And in addition, they've actually annotated the model so that you can have a bit of a tour of the area. So that's one example. On the right is a black steatite cypress, which is part of the British Museum touring exhibition Ancient Lives. A cypress is a stone pillar, usually inscribed, that was used to mark things like events, boundaries, or grave sites. This 3D facsimile was created from 145 photos taken with a 1+3 mobile phone, split into two chunks and then assembled in PhotoScan. And we'll take a look at that so you can see sort of the difference here in the types of photogrammetry that are possible. And what I think is so incredible about a model like this is the level of detail that we can get on these kinds of models. If you're a scholar who's studying hieroglyphs, right, this is the type of detail that you're really never going to get unless you can be there in person with the object. And even then, depending on whether or not you can handle it, right, you might not even be able to get this close. So it's really pretty incredible. As you likely know, there are many roads that will get you to the same destination. This is a guide that's only about a year old and gives some good advice regarding equipment and techniques that can supplement what I share with you today. Obviously, there's a lot of stuff out there. This is a really big field. And what I'm showing you today is sort of some of the basics to get you started. Here's just a sample guide to let you go even further if you're interested. I also want to note that through Software Central at UCLA, you have access to Autodesk products for free. Autodesk is one of the leaders in the field for this kind of software. If you're interested in learning to use one of these tools, please let me know via email or in today's exit survey, and we will add it to the workshop roster. These are a little bit sort of more standard fare in professional circles. What I'm using today is open source, so it just depends on what your cup of tea is and what you want to train for. So the tool I'm using for today's demo is called Meshroom by Alice Vision. And like I said, it's free and open source. To get started, you will want to go to alicevision.org and click on the Meshroom in the menu at the top of the page. Unfortunately, it's only available for Windows and Linux operating systems. Before you can download it, you will want to check what kind of graphics card your computer uses. You will need an NVIDIA card and not a Radeon. Radeon is typically found in gaming computers, but most general use computers have NVIDIA, but check the specs just in case, just to be sure. Also to note here, photogrammetry does require a lot of graphics processing. Careful not to try this on a machine that doesn't have that level of computing power. If you're not sure what to Google to check or what settings to look at on your computer to check, and you don't want to risk it, feel free to just follow along today and we can talk later or over email to confirm if this is something that you should try on your system or not. I also want to note that my colleague Rafaela worked really hard to begin installing Meshroom on the high performance computing cluster for us. We couldn't quite get it ready in time for today's workshop, unfortunately, but I will do a follow-up workshop or a tutorial when it is ready so that you can make use of the cluster and not have to be limited by your own computer's CPU or GPU power. And if you're not familiar with the cluster, I recommend that you check out one of Rafaela's workshops. She's a great instructor and will help get you started. And if you're interested in learning about the cluster, you can reach out to me or to Rafaela. We're always happy to answer any questions you have. So once you've downloaded the software, you will need to extract the files, and then you will launch the program by clicking on the meshroom.exe file. You may get a pop-up saying that the software isn't recognized. That's okay, go ahead and tell it to run anyway. It's perfectly safe. So when you open Meshroom, you will have a panel on the left to add your images, a central panel that will let you preview images. So this is where you drop your image files. This is your image viewer where you can preview those images. And the panel on the right with the circle is where your model will be produced as a point cloud. So that's over here. So this kind of set of circles. At the bottom are the nodes, and I'll talk about those more in just a second. Now at this point, we need some images. To capture an object, flat lighting is best. If you're shooting outside, aim for an overcast or cloudy day to avoid big shadows. Those shadows can get baked into the texture or the photographic or image file overlay that happens to give your objects their realistic texture. If that happens, it may make lighting the object in the virtual environment later on a little bit more tricky. Like I said earlier, you don't need a fancy camera to make this work. I'm using a camera phone for this demo, as you can see here in these two screen recordings. Now, I have some helpful equipment to make this a little easier, as you can see. I have an electric Lazy Susan that I placed my object on, but you can use a regular one or just walk around the object equidistantly, taking lots of pictures from different heights and varied angles. Coverage is what's most important, and the more pictures you take, the better your model will be. I'll demonstrate exactly what I mean by that in a second, And I'll just hit play on this again. So you're, oh, hold on, let me go back. There we go. So let's play again. Oops, sorry, I'm not sure why that's doing that. There we go. So like I said, coverage is what's most important, and the more pictures you take, the better your model will be. I've also done my best to make sure I have lighting that doesn't cause that much shadow, and I placed a board behind my object so that the background is less busy. This will help the computer process things a little faster and will make it make my cleanup of the object a little bit easier in the aftermath or in post-production. Since it was near the holidays when I started this workshop, I selected this ornament that may look familiar if you've ever seen the movie A Christmas Story. It's the infamous leg lamp. It was a gift from a friend of mine since I'm a big fan of heels, but I thought it made for a fun object to capture. So for this walkthrough, I did two versions, one with very few images and one with a lot, so you can see how it affects the results. When taking a lot of images, I recommend using burst mode on your phone, which is what I'm showing here on the right-hand side. Well, in both of these videos, I'm going to replay this one again so that you can take a look at that. From there, you will want to select each image with the burst mode. It's okay if you miss one or two here or there, and add them as individual images to your device. I've chosen to upload them into Google Drive just for ease. And as I mentioned, for ease, I've uploaded these images into two folders for you to use. You can click on one of these pictures to link to them. So each one of these pictures are linked. So if you, again, download the presentation for today, you'll have access to those links. One of the folders contains just a few images and one with a lot. I'll walk you through what running each of these sets of images does in Meshroom so you can see the difference for yourself. So once you've downloaded the images, extract them and then drag them into the image panel on the left side in Meshroom, right? So you're just gonna extract them like a zip file, and then you'll drag them into Meshroom. Now, nodes are essentially the types of computation that are happening on the image set and the order that they are getting processed in. The most important ones for us are these that are happening at the end, which are meshing, mesh filtering, and texturing. And if you click on these, you can adjust things like resolution, smoothing, and the levels of data that you want baked into your model. So you'll want to take a look at these and make sure that the settings are just what you want before you get started. But before you can even process, you have to save your project. So you'll create a folder and save your project in it. Once your project is saved, hit the start button at the top and begin processing your images through the node workflow. So just here at the top, once you've saved, right, you'll just go and hit this green button, right? These are you can tell that these are the images that are selected, and that will start running through those various different nodes at the bottom. When the top button switches back from stop to start, so up here, when it says start again, you'll see that it's kind of grayed out over here. That becomes red and says stop while it's processing. Then it turns back to green and says start again once it's done. Below your image panel, you'll see the number of images you attempted to process. And it looks almost like nothing is there on this first run through, because we only did 12 images, right? And you can barely see anything there. If we double click our mesh node, so this mesh node down at the bottom, or on the side, you'll see over there, we can sort of see an outline of the object, but it looks really messy. It actually looks more like, Italy, the boot. So you have sort of the top of the lamp here, that's the leg. You can sort of see the heel at the end, but it's very messy. Now, if you start over and try it with the bigger data set that contains over 200 images, this will take a very long time to process, over 30 minutes at least, hence why this presentation is canned and not a live demo, but you'll get a very different result. Here's a screenshot of what goes on with your computer when you're running these photogrammetric processes. As you can see, it takes a lot of computing power. Your machine may get loud and hot, and you'll want to make sure you're not blocking the fan area or anything like that when you're running this. So that's why it's very useful. It'll be very useful to run Meshroom on the high performance computing cluster once we get that running. So again, check back for that, because I think it's going to be a really great thing if you're interested in doing this kind of processing. So by double clicking on the mesh and texture nodes, we can see our point cloud turn into something that resembles a model. So if you double click these down at the bottom, you'll start to see they'll show up here on the sides, and then you can see different forms. So this is, and all these little things around, let me go back. All these little things around, these indicate where the camera was when it took a picture of the object. So you can see that's over 200 pictures circling around this object. And you can also see where we have some gaps, right, where we didn't capture. So now we didn't get a full 360 degree coverage, but we did pretty good. And again, you can use the eye icon to turn on and off mesh and texturing views to view more clearly what's there. And so here's a close-up of the texturing, and you can even see the detailing on the fringe from the lamp and a bit of the fishnet stocking pattern, which is pretty cool. So we did get a good capture in that sense. So Meshroom gets us part of the way there, but we need to use another tool to finish our model. In order to do that, we need to take the files that Meshroom is storing in its node cache and save them out. And we do this by right-clicking on the texture node and clicking on Open Folder. Then we want to copy and save out the PNG, the MTL, and the OBJ files. And you can save them to whatever folder or place you've been saving your main Meshroom files to. And that's because these are the files that have the information about the texturing and that sort of the photorealistic top layer that we want to add to the model. So the way that we do this is we'll use another program called MeshLab, which is also free and open source, to clean up our model and get it ready to be ingested into any 3D viewer platform we choose. And you could also use a program like Blender for this, which is also free and available for both Mac and PC. So this, as well as available for various different operating systems. It's really whatever program you prefer. And you may run into warnings again about downloading and running MeshLab, but it's perfectly safe. So this is not unusual for open source software. It's safe, and you will want to install it and run it. So just click through the prompts as you would usually do when you're installing a new application. So to get started, you will want to go to File and then Import Mesh and load in your object file from Meshroom. that you just exported. It looks dark and we've got all this messy surface stuff around the bottom and a bit at the top, right? So we've got this kind of floating stuff. And this is just additional information that when we created our model got rendered into the model, right? And we don't want any of that stuff in our final product. We just want the lamp itself. So if we want to share nice clean objects, we're going to get rid of all that extra stuff, and we can do that really quickly in MeshLab. So you'll choose the Select Surface tool from the menu and then reposition the item, just dragging, clicking and dragging it so that you can begin to select the excess to be cut off. And I'm sorry that I don't have a screen recording for this, but looking from the top or the bottom seems to work best for this type of an object. And you'll just figure out, depending on what it is that you captured, what are the best angles to sort of do this kind of work at. But whatever's in red is selected, and you'll just go carefully. So you'll hold down the control key and the control key to keep drawing more and more boxes, selecting more and more of the area until most of it's red. So essentially you're just going to click, drag, and sort of form a box. And each time you do that, you'll select more of the model. And once you've done that, all of that, whatever's red, is what's going to be deleted. So when you're ready to get rid of what you've selected in red, you'll use the delete icon in the far right in your menu, and all those areas will be removed. And again, you'll repeat the process for anything that's left over. So for example, you'll see here, I cleared away this first bit, but then I saw there's still this floating bit and there's some down at the bottom. And so here you can see sort of that the box that you create. So you click and you drag and you can capture parts of your model. So you'll just keep spinning the artifact and keep clicking and dragging till you select all the bits that you don't want as part of your model. And when you've finished, you'll go to File and then Export Mesh, and you can leave the settings as they are and click OK. Obviously, this program can do a lot more than just editing down the files. That's just what I'm showing today. If you're interested in learning more about how to light an object or do additional kind of cleaning methods, again, please include that in the exit survey for today. It's really helpful to know what it is you want to achieve in your work. So while the file will export the OBJ to replace the OBJ that you imported, it will also export a .obj.mlt file. So that's your OBJ with the texture attached to it. And now you're ready to use the mesh or model in other programs, or to share it using a 3D viewer. For example, I uploaded the model to Google Poly. I don't know if any of you are Google Poly users, but unfortunately, Google will be discontinuing Poly in June. For those of you who are not familiar with Google Poly has been a repository for 3D and 360 work, and a lot of real estate agents, but as well as artists and educators have been using it. It was free to use, which is really a great service that Google was offering, because these files can be quite large, and storage is often sort of one of the more difficult barriers to doing this kind of work, is that you need to have a place to be able to store these objects. So it was nice to be able to use Google Poly, and unfortunately that won't be able to happen after this summer. But many museums are using Sketchfab as for their 3D repository, and you can get a free account with Sketchfab with limited storage. And then depending on what your storage needs are, there are sort of subscriptions that you can look into. So in Poly, I played around a bit with their built-in tools. So I added a bit of gloss and a metallic look and fixed the lighting a bit since it came in quite dark. And it looks a bit more like an ornament now, right? Again, it wasn't perfect. I didn't sort of get this final bit at the bottom, which I probably should have in order to make it look very clean, but it does have that ornament feel now. So I'm going to pause just for a second to see if anybody has any questions. That was the introduction to photogrammetry and a basic workflow of how that goes. And we'll jump now into LiDAR, but does anybody have any questions before we do that? No? Well, feel free to add any questions you may have in the chat, and I'll take a look at those as I work through LiDAR. So LiDAR was developed shortly after the laser was developed in the early 1960s. LiDAR is a method for measuring distances ranging by illuminating the target with laser light and measuring the reflection with a sensor. Differences in laser return times and wavelengths can then be used to make digital 3D representations of the target. So this isn't dissimilar from something like sonar, which uses sound in a very similar way, or radar using radio waves, right, does a very similar thing. LiDAR just uses a laser. And this little video here on the left is great for just an introduction to what LiDAR is. And on the right is a diagram from a recent article that I think visualizes fairly well how LiDAR works. The video, I should say, also talks about some places you can access open LiDAR data, like the National Ecological Observatory Network, or NEON, at neonscience.org, in case you're interested in that. While long used in the earth sciences, LiDAR is becoming increasingly available to all of these different fields, and because it's being added to cellular mobile devices, increasing its academic and commercial potential. So I'll let you view that video on your own. So LiDAR is now available in many of the new mobile devices. iPhone X's and above have LiDAR sensors built into the front-facing camera, and the iPhone 12 will have it in both the front and back-facing cameras. Now, I know these cameras are expensive, around $1,000, but professional LiDAR scanners can cost anywhere from double to 20 times that. And this is a phone, so it has other types of functionality for that price. And these mobile LiDAR scanning apps that I will introduce you to today are fairly powerful and easy to use. So depending on what the project is, this may be a really good way to go. I'm just going to quickly turn the sound up on these videos. So while the higher end apps are pay to play, there are several free applications that are available to use with your mobile LiDAR devices. And in the time we have left, I'll just speak to three. The Scandy Pro app, and you can check out scandy.co to hear more about their products and services, is compatible with iPhone X, XS, XS Max, XR, 11, 11 Pro, 12, 12 Pro, and the new iPad Pros, 2018 or later. You can save one free color mesh from a scan each week with 54 gigabytes of free space, and share files as .ply, .stl, or .obj formats. All rendering is done on your device, and there's no need to register for or store files in the cloud, which is really nice. If you purchase a subscription, and there are several types, you can try a week for $2. You can do a month for $6. You can do a whole year for $50. Or you can get a lifetime subscription for $100. And with that subscription, you have unlimited saves. So depending on the length of time that you need it, that might be a good way to go. The app allows you to do a world scan using the LiDAR sensor on the rear of your device to capture room scale scans, or an object scan, which uses the true depth sensor on the front of the device to capture higher resolution scans. Their app has several tutorials, which you're seeing a preview of here, so I won't take you through that process, and rather I'll just let you review it on your own time, but it's very similar to the photogrammetry process, except for the fact that the scan is capturing sort of everything at once, and doesn't have that sort of stitched together time in the same way. However, I do want to offer advice based on my experience using this particular app. The woman in the tutorial holds the camera, as you can see here on the left, herself and simply steadies her arm on the table. This didn't really work well for me. While adjusting the sensitivity of the scan can help with this, I highly recommend getting a stand that can hold your camera for you so it doesn't move during the scan. I also recommend getting something like a Lazy Susan to rotate the object if your object is small enough. Another thing I'd note is go extremely slow, slower than you think you need to go, to avoid too many red flashes. Those red flashes indicate that you've lost your scan position. As you can sort of see here, as she rotates, it'll occasionally flash red, and that means that she's sort of lost her scan point for a second. As with photogrammetry, the less stuff in the background, the easier the scan will be. Also, the app can import scans, so you can use Scandy to edit other scans that you may have. So you may end up wanting to use Scandy just for edits. So I'm going to quick play this video. Again, it's a screen capture that I did of using the 3D scanner app. And this is a product by MeshLab. This app is also free, but it requires a LiDAR camera sensor device, such as the iPad Pro or the iPhone 12 Pro. And you can export in the USDZ format to share your scans in iMessage or AR Quick Look. Additionally, you can export scans as OBJ, GLTF, or GLB files. Those are good for Mozilla Hubs, which if you're interested in learning more about Mozilla Hubs, which is a web VR platform, you can check out my tutorial on the Idri YouTube channel. You can also export scans as DAE or STL files. If you prefer a raw point cloud, you can export as PTS, PCD, PLY, and XYZ. You know, that's a lot of alphabet soup, but these are a lot of different 3D model types. And that can be really useful depending on what you want to do with your model. So you can see with these file format options, you can import your scans into many 3D model programs like Blender, 3ds Max, SketchUp, Maya, etc. And you can also edit your model in the app. There are no signups required for this app either, and you don't need cloud access or an internet connection actually to use it. So additionally, there are no limits to the amount of scans that you can capture, which is another plus to this particular app. There are a few other features I want to highlight. You can measure your scans with a virtual ruler, allowing you to capture height and the height and the width of your model. And I'm just going to fast forward in this demo a little bit so that you can see what that looks like. This is in edit mode. Let's see as that loads. So you can see I'm attempting to edit some of the background that got incorporated as I was doing my scan. So I'm just going to go a little bit forward in this. And again, I'll just sort of indicate it here while we're waiting for it. So measure down at the bottom allows you to check the measurements of the object so you can get an immediate sense. It'll tell you in inches and feet how big your object is. So that can be really useful to be able to just capture that free form really quickly with an object. You can also view your 3D scan models in the augmented reality viewer. That's this AR button up here in the corner. Again, if you watch this video all the way through, and maybe we can just fast forward real quickly and get to that point. Again, this is editing out some of the background. You have many different background tools in order to do that. Fast forward. Here we go. So you can see here, bringing the model in AR. Because I didn't quite get the right spot on the first try. So again, if I just back out, hit that X in the top right corner or top left corner, and then try again, I can actually place my object in the space using the AR viewer. So again, this is a model that I want to spend a little bit of time, mainly because there was shadow light, morning light coming in, and so I got a little extra around the top. So I want to take the time to edit that out. But you can see here, I can text my model to someone, or I can use the share feature down at the bottom and export it in a bunch of different formats, which is really useful. There we go. So there's the measuring tool. That's what the measuring tool looks like. So you can see I can instantly measure my object. Okay. So first, let me mute that. So for scanning a whole room, you may want to try Canvas Pocket 3D Room Scanner, which is free to download from the Apple Store. It requires an iPhone 8 or above. Currently, this is used by many home improvement professionals, such as design build firms, kitchen and bath remodelers, general contractors, architects, interior designers, and the like. The scan to CAD feature does have a fee per model, but it allows you to convert your scans into editable professional grade CAD files. It has output to SketchUp, Rivet, Chief Architect, 2020 Design Live, as CAD files, as well as 2D floor plans in PDF and AutoCAD formats. As you can see here, there's a tutorial that's linked if you're interested in getting started. So I'll leave things here for today. I know that was a bit less time. I wanted to make sure that we had enough time to get through everything today. Thank you so much for your attention. Here are a few of my other tutorials and resources if you're interested in learning about other extended reality technologies. I'm building out tutorials all the time, so let me know if you have anything specifically you want to learn or if there's a tool in particular that you're interested in. I'm always happy to help. And with that in mind, please take this 30-second exit survey before heading out. I welcome your feedback. I look forward to reading it. Thank you so much for your time. Right now, I'm going to stop recording and I'm happy to answer any questions that you may have.